So, the first thing that we're going to go through is the domino part of this video. And the domino part is mostly a exercise of how to organize a Houdini file and how to use the basics of nodes and of the rigid bodies solver. So the first thing that we're going to do is create a ground plane. The ground plane is nice because it interacts with the stuff in the scene. So when we create other RBD objects, it will interact with this ground plane. Good naming convention, double click to name, so we'll just say ground. And then auto.network is kind of just how everything interacts with each other. So double clicking on a node will let you go into the node, and it's basically a hierarchy form. So you can go into tree view and you can kind of see how it works like that. So that would be a node, and this is inside those nodes, and so on and so forth. To tumble, it's kind of the same thing as Maya. So Alt, left click, zoom out is right click, going in and out, and then, yeah. Pan is also Alt, middle button. So what we're going to do is we're going to take, let's just say a box. So we'll try to learn how to do this in the node. So you can press tab. This will bring up a search thing, and you can write geometry. So that will search all the tabs, search all the nodes possible, and pick up whatever you're typing. I'm just going to write domino 1, enter, and then I can double click, go inside here. Here, I don't want to upload a file, so I'm going to delete that, and instead I'm going to create a box, and that will be our first domino. So I'm going to go tab, transform. So I'm just going to, it's a domino, so I'll just say width is 0.5, height is 1, and say the thickness is 0.1. That's how that looks. Yeah, it's pretty domino-y. So, and then what I'm going to do, I'm going to translate it upwards. The cool thing is if you middle click on the translate or any of the parameters, it will allow you to drag and then, different increment levels. That's really nice. Yeah, so here we have that. So this, let's just say this is our domino one. Blue is what you're seeing in the viewport here. So if I went back to box, it would be before the translate. And then same thing, it kind of affects what you're seeing. Yellow means bypass, so it'll skip that. So let's say I also went and did another transform. And then I said I wanted it to global scale, uniform scale to 4 to make it massive. If I skipped this, it would go back to being a cube. It would be uniform scaled up to 4, but it would be back at the cube. And then another thing that's useful is to help organize things are net boxes, network boxes. Network boxes, I can say dominoes 1, and then put that in there, and then you can move it around. So let's say I wanted a second domino, I could be like, oh, this is domino 2, but I still want it to be in the domino 1 area. There we go. And then you can move them both around. That's really easy for organizing. So let's just say I wanted to do this, and I could copy paste that, and now I have domino 2, 3, and 4, which is super cool. So from there, I'm just gonna, start pulling them out. I'm not going to do a full one because obviously it'll take a lot longer, but this is the gist of it. And then we need something to knock it over initially. So let's just go with a sphere. This is another way to do it. So instead of doing the tab geometry, you could just use the shelf up here. And then what I'm going to do is I'm going to take this, I'm going to put it up here, put it up here. So yeah, so this is like kind of our setup, but nothing is really interacting yet. So let's just take, for example, the sphere first. The sphere is going to be a RBD object. Or RBD object is rigid body dynamic, so it's really easy. You just click it, and now it will have physics. So if you scrub in the timeline, you can see, oh look, that was easy. So now we're going to go, let's just say dominoes 1 and domino 2, we want to also make them rigid body object, dynamic objects. So you click that. Whoa. And then here we'll do it for these ones too. There you go. So that's kind of how you do it. There's also static objects. So let's just say instead of a rigid body object, I wanted to make another one. I want this one to be a static object, so I'm just going to add another one. So here we have a static object. And you see it does not actually interact with the physics, but the things around it interact with it. See, it won't fall. So, and then the last thing I wanted to go over in this lesson was the materials. So this is just basic materials, and I kind of just wanted to show more so for the grouping, how easy it is with the grouping. But you could just go, you know, I want plastic because my dominoes are made out of plastic. Oops. Drag that in here. Maybe pick lime green because lime green is the best color in the world. And then object. We'll just go like, oh yeah, I'll just choose all of these. And I'm just going to assign these. Look, now both of them are. So that's how I got it to do, like, especially with all my giant domino effects and not having to individually assign shaders to all of them. We're going to move on to the smashing success. So that's basically a quick rundown of the destruction, the bullet. So I can't take much credit for this one because I followed a lot of tutorials for this one, but I'll still give you a quick rundown. So we'll start with the ground plane just like last time. And we'll open a GeoNode. So again, that's tab to get that menu to search, and then geometry. You go in there. For mine, I used a OBJ of like the text word success. And if you did that, then you'd also do like a convert to get it into polygons and just, yeah. But for this case, we're just going to use a box to simplify things. And then what we're going to do, here's where it gets more complicated. You're going to go Voronoi fracture. And in order to use this, you also need a bunch of points from where it will create the fracture point. So we're going to do scatter, which basically means it will kind of make points all along the object. And just because we don't want to be waiting in this video for a bunch of things to load, we're just going to minimize the total count of points on the surface. And so we have the object going into that node, we have the points going to that node, and now you can see, whoa, it's all fractured and stuff. That's cool. So yeah, here is the object that will be fracturing, and then lovely Houdini has a button for that. So we go RBD fracture, and then even if you start playing it now, you can see how it falls apart. But we don't want it to fall apart until there is actual impact. So what we're going to do, I forgot to name this, wall. We're going to again, there's a button for it, but it's glue adjacent. So glue adjacent, down here it says select the RBD objects to glue together. We kind of want to glue the entire wall, so we're just going to hit enter. And now you can kind of see the glue constraints between them. And so if we continue and load the entire scene, oh look, it's staying together. So now we kind of want to create an object to hit this thing. So we'll just create a sphere. So geometry, go in there, double click, tab sphere. And then what we're going to do is, well, let's shrink that because it's kind of really massive. And then we will move that off to the side here along the Z-axis. And just like last time, we want this sphere to be a RBD object. We want it to interact with what's going on. And then, of course, you have to restart the simulation. But what you want to do is okay, everything kind of got away. Space G centers everything. It's a useful little thing. Auto dot network, as I said last time, it kind of is showing like the interactions between everything. And so GO2 is the sphere. I want this to come and whack the wall, so we're going to go, this is the, you have the little axes over here, so you want to go forward in the Z direction, so we're going to give it a velocity of maybe 50. Whack it real hard, and we'll see how that turns out. So now it has a velocity of 50 starting off, that's the initial state, and if we load, let's see what happens. Ooh, there you go. So, and you can see it kind of really stuck together. Here, it's the glue held really fast. So if we wanted to change that, in the AutoDop network, there's the glue constraint that we created, and we can change that. Instead of being this crazy strength, we can go like, oh, I just want it to be like 0.5, 0.6. And we go again, load that, and we can see that the constraints held a lot less smashed. So I also added particles. I'm not going to cover that here though because it will be covered in the next video. So we're going to go, I'm going to show you the human who is exuding particles. This is the one I'm going to spend the most time on because it's the one that I actually did the most personal R&D and less tutorial following. Basically what I did for this one was I had the human who was motion captured, and then I added some particles to the human based on the velocity of the movements, and yeah, I made the person look cool. So now what we're going to do is import the Alembic cache into Houdini. So for doing that, we're going to go and create a geometry node. Inside the geometry node, it is a file, but we actually want it to be an Alembic, so we go tab Alembic, there it is. So now we have our human. So this is our movement. From here, what I did was I converted this into polygons, so from whatever it is into polygons. And then what I did was I added a trail. So trails can look cool even on its own. You can see, whoa, it's like motion blur. And you can change the trail length so it's like super fancy. And that looks cool, but that's not what we're going to use it for. We're actually using it to compute the velocity, and that will actually go into the particles. We're going to create a POP network, a particle operator network. And here you have the source of the particles, and you can see that the geometry source is the first context geometry, and that is this one because I put the trail into the first little button thing. So now you can see that it's creating the particles on the geometry. It's kind of a mess right now. So first thing I'm going to do is I'm going to go into the source, right? So that's what we were in. Again, this is in the object, in the geometry node, into the popnet, and then on the source first input, birth. So first of all, I don't want the life expectancy to be long because that's just going to make it really heavy in the end. I'm just going to make it 1. And then so at least now they're dying. But now you can kind of see that these particles are kind of going crazy. There's like a bit too much speed to them. So what I'm actually going to go do is in the trail where you're computing the velocity, I'm going to scale down this velocity by like, I don't know, 0.2. Let's try that. Let's see how that looks. Yeah, see, that's a lot better. Then in mine, because I kind of only wanted the swirls to come from these large movements and I didn't want to have that like body, what I decided to do is to only show the particles that were coming from a movement that was very large. And so in order to do that, I created a pop kill node. Pop kill like kills particles. It might not be the most efficient way to do this, but it's the way that I found that worked. And so this is Vex expression. It's kind of like the coding, the scripting language for Houdini. And what I did was I created a variable that was the speed. So we'll go, it's a float speed is equal to, and then because I wanted it to be like a certain speed, but it can't just be plus or minus. So then I went with the square root of v, and at is like getting the value. So it's like velocity y times at velocity y plus at velocity x times at velocity x plus, I mean, I guess I could also square it. I haven't actually checked to see if the little hat 2 would work. So for the sake of this, we'll just do the slow one just because I know it works. Close that, semicolon, because it's just that kind of code. And then I'm just going to say dead is equal to, let's just say, anything with a speed over 5 is smaller than 5. Sorry, smaller than 5 will kill. So we'll have a ternary expression, kill it, or if not, just let it be. So now you can see it's only coming from the head and body. So yeah, obviously in mine I had more particles. I don't want to put too many more particles in this one just because it will be a pain, and this is just a demo, but yeah, it's pretty cool. And then another thing I did after that was I added another trail. I added another trail, but this time it was like the actually like trail and not just the velocity, just so it would kind of be smoother and cool. Yeah, and then after that I changed the color. So in order to change the color, I used an attribute VOB. So attribute VOP. I tried multiple different things. I was just going to do the age of the particles. Yeah, here you can kind of see the age of the particles, because that's what I've been doing for a lot of other things, but I decided that the age kind of just both hands melded together, and I didn't really like that look, so instead I used the velocity. But then, of course, using the velocity, I needed to normalize it again for the same reasons last time. So I went absolute, I said normalize, but I meant absolute value. So we're going to use the velocity. So this is the value for velocity, and then we're going to put it into this absolute node, which will, it's kind of like a math node, make absolute. And then, because we're going to end up putting this into a color ramp, actually we'll make that first. Ramp parameter, and then we're making it a RGB color ramp. And this, of course, will go into CD, which is color. So that's output is going into the color, and then it'll color the particles. And then we want to put it in the input, and then you can kind of see, oh look, it's the age of the particles that's kind of messing it. But what you can see is like it's very shortly one color, and then it goes to white, which is the way the ramp is, except the reason why there's so much more white is because it's not in the right, the color is from a scale of 0 to 1. So what we want to do here is we want to remap the value. So what I'm going to do is I'm going to do a fit range, which just remaps values. So I'm going to say the source goes from 0 to 20. I'm just going to assume that 20 is the maximum speed, but you would have to change that depending on your what your values you're using. And now you can see, and then of course destination is 0 to 1. So now you can kind of see that it's based on the better, it's better now. So the speed is better now. I said age earlier, I meant speed. Yeah, so that's the gist of it. Here, I kind of just like, I like blue colors. And you can change it up. You can make it like a peacock. You can make it really ugly. It's up to you. Whatever floats your boat. So we're gonna go back and, because this person you can see doesn't have his body anymore, which is fine, but I'm gonna, it looks cool anyways, but I'm gonna add the body so I can show you what I did with the body. So I'm just gonna make it in a new node, delete this, import the alembic, like last time. So now we have the body. And what we're gonna do here is we are going to make him all puffy and stuff. So we're gonna convert into polygons, just like last time. Doesn't look anything. Then, because I kind of I didn't want it to be a solid color, I added noise. So what I'm gonna do is I am going to create an attribute, VOP, go into the attribute VOP. So if you don't remember, this is kind of what we did to change the color last time, so we're gonna kind of do something similar. We're gonna make some turbulent noise. I'm gonna just go, because I want it based off the position of the on the human. And then I'm gonna go put that into position, position here. And then again, because I'm going to be putting this into the color, I just want to do a fit range to make it from 0 to 1. Yeah, so let's just close that for a second. And lo and behold, look at that, fancy. So then what I did is I wanted to make this person puffy. And in order to do that, this was just a lot of experimentation to see what actually looked good. I personally liked the extrusion. Poly extrude. Here we go. There we go. Then you have the distance. But this is kind of just making them scary and skinny all in one. So instead I'm going to do individual components, and that way it's literally individual components that are the individual faces that are being extruded. What I don't like about this is how it's, when you go positive, it's going inwards, and negative, it's going outwards. And that's because when I was doing my alembic, all my normals are facing weird. So I'm just going to add a reverse node in there to flip those normals. And yeah, so now we kind of have something similar to what I had in mind. Yeah. You can also plug in values, so it's not extruding just all the same. Like you could potentially extrude based off of the color of the skin, or of course like the speed and stuff, just like what we did before. But when I was playing around with that, it was too distracting from the other effect that I wanted to be the main. But it would just be through vex expressions, just like we did last time with the particles and with the with things like local variables that you can call from the object. So yeah, and so now if you put the two together, you have like, whoa, very cool. And the sphere itself was done pretty much in the same way. Let's just make this a little bit bigger. I use this as the source. I added more animation into it, so one way, I guess, something that I haven't explained is animation. Kind of like Maya, you have a timeline here and you can frame things. And then again, just like what I did last time, I had the sphere. This one's already a polygon, so it's fine. And then I added a pop network to use this as the source. Do our transform in here. Transform node, we'll scale it to 0.5. Key that at 25. And then we'll go to 45. And we'll make that whatever this is. Yeah, cool. So, I messed that up. There we go. It's gradually growing. So then we go into PopNet, just like last time. I personally do not like the long life expectancy, so I'm going to make that smaller. I don't like how it's not making a lot, so I'm going to make birth weight a bit bigger. And then you can kind of see it's like boring. The particles aren't moving. So another thing, this isn't what I did in mine, but it's good to know. You can add like pop force. A pop force will kind of add some swirl to it, or you can just do like XYZ force, like if wind or gravity or whatever. I like having a bigger scale, so it's a bit more flowy. And then that way you can kind of see it's going like, whoa. It looks silly when it's the first one, but then it looks cool when it gets bigger. And then you can keyframe those are parameters too. And then the other thing that I did in mine actually, to get a cool effect that you don't actually see because the human's in the way, but I used a metaball. I use a metaball force, and you can use these to kind of repel or attract things to it. I kind of put it around the particle emitter. Right, so with this metaball, this giant metaball, make sure it's surrounding. And then what I'm going to do is I'm going to, in this pop net, I'm just going to go like, oh, you know what? We'll go into the particles shelf and we'll go, I want a metaball force. And then I'll say, select metaballs first, metaball force, select that, enter, there we go. So now we have a metaball force. And then the force scale, you can either attract or repel. So in this case, I want to attract it. And then what's cool is that because it's always attracted to the center, it'll kind of boomerang back and forth. Oh. So yeah, you can kind of volleys back and forth. So yeah, if you color it based off of the age, then you'll get different colors waving outside, and it looks really cool. I'll just hide that for now. But yeah, that's like a cool look as well. And then yeah, you can either have the trail like a fake trail, just using force. I'll just say pop drag, which is a drag force. Let's just say I want it to go like wind velocity, -10. And then you go back and it's whoa. And that's how I kind of did the energy ball. Yep. So that's it. That's the end of the tutorial. And I hope you learned something. I hope this is what you were looking for. If not, that would be awkward.